Hello all, and welcome back to the packed course on Python Digital Forensics. We'll be starting our final section, which is threat emulation, or attack. This section will give you knowledge on how an attacker thinks and operates, and better our methods in digital forensics. The first lesson of this section is enumeration. This is the process of finding and understanding what is on the network. So for this lesson, we're going to learn about the threat lifecycle. We're going to learn about common enumeration steps and types, and we're going to build a Python-based network scanner. The type of network scanner we're going to build is a ping sweeper. So required materials for this lesson is you're going to need the Python module subprocess. Subprocess allows you to spawn new processes and connect to standard input, output, or error pipes. This allows you to issue system commands from our Python application. You're also going to need any VM or machine connected to a network. For this lesson and the upcoming lessons, I'm going to be using the Metasploitable VM, which you can get at the link below. First off is the threat lifecycle. This is the general methodology of how an attacker will find, exploit, take advantage of a system. It's by defining their targets, building and acquiring tools, researching a target in its infrastructure, test for detection, deployment, and initial intrusion. The enumeration steps in which we are focusing is between deployment and test for detection in developing tools. This is knowing and understanding what is on our network, or knowing and understanding what the potential threat vector is for an attacker to exploit. So a quick intro to Metasploitable. It is an intentionally vulnerable virtual machine. It is based on the Ubuntu operating system. It comes preloaded with all sorts of different types of exploits and threat vectors. You can use this to learn and get an introduction to penetration testing. It comes from the makers of Metasploit, which make the Metasploit pen testing framework. So let's begin a demo of building our Python ping sweeper for enumeration. So let's begin by building our Python ping sweeper. We're utilizing Python 3, and therefore we label Python 3 shebang. We import two modules, subprocess and sys. We're going to be using sys for our input, output, and our standard error. Subprocess is going to be utilized in order to make system-level calls. It's going to be used in order to issue system commands. In this case, the command we're going to issue is ping. We're not going to utilize argparse in this module because of the entry of the IP address. So instead, we set an instance variable of the IP address with a string that is the first three octets of an IP address. In this case is 192.168.56. And note the dot at the end. We're leaving out the last octet of an IP address so that way we can vary this number. Our ping sweeper is going to scan 192.168.56/24 subnet. So this means all IPs between 192.168.56.1 and 192.168.56.254. So in our if name, we instantiate our ping class and call the main function. So let's build out the main function. Since we have the IP address set, we are now going to loop through all the values of the last octet that we want. So the best way to do this is a for loop. And we are going to use the range function. We want our range to start at 1, and we want it to end at 254. So we're going to type in 255. The way the range function works is it takes the first argument as the start and the last argument as the end, but is not all inclusive. So this range will get us all the way to 254. Now what we want to do is issue the ping command. If you're not familiar with the ping command, this is the syntax. I have the Metasploit VM running, and the IP address of this VM is 56.101. You can find out by issuing an IP space A. So the proper syntax for pinging this device would be to ping and then the IP address. Now the Linux version of ping does not have a count or a timeout. Now the ping command in Linux does not have a counter. So it will keep going indefinitely until you kill it by issuing a Control-C. You can put in an argument, which is taxc, and the number of times you want it to ping. So if you get a taxc 3, it will ping the device 3 times. So back to our Python code, we want to issue the ping command. And we're going to do this using the subprocess module. I'm going to set my subprocess module, or my subprocess object, as the variable p. And we're going to be using the popen function of the subprocess module. The arguments you want to give popen is the command you want to run. So we want to run ping. This command needs to be in a string format. We want our count to be 1, and then we want to insert the IP addresses. so we're going to use a stringed-out format. The first value is going to be our first 3 octets, which is self.address. The second argument, and the second value, is going to be what our range number is. This is a value that will vary between 1 and 254. The next argument of popen, so we want to open a shell, and we want to send all of the data to standard error. This keeps it off the main screen, which is standard output. We do this by setting standard error equal to the subprocess pipe. This will effectively iterate through all the 192.168.56 legitimate IP addresses. But we still need to process them. Just because we can ping all of the IP addresses doesn't mean that a network device lives or answers to that IP. So once we issue the ping command for a particular IP address, we want to listen for the result. For example, if we pull up our ping commands and we issue it to an IP address that doesn't exist, you'll see that we end up with a destination host unreachable. We need to capture this, or more specifically, we need to capture it when it succeeds. So to do this, we're going to set up a while loop and a new variable called out. We're going to use our subprocess object that we set up before, which is p, and we're going to read standard error, which is where we piped our output to. And then we are going to check our out value and see if anything exists. And then we're going to check our out value and see if it contains any data. If it doesn't, we're going to break out of the while loop. If it does contain data, we are now going to write to standard out instead of standard error. This keeps the screen clear for entries that are valid. And after you write to standard out, you should flush the buffer so we don't have any information that gets carried over into the next write. So now we should be able to run our application. As you can see, I killed the process early, but this application writes out the status of every ping. So we can see we have a device that lives at 56.1 and a device that lives at 56.2. And if we kept it going, it would scan the device that is at 56.101. The 56.2 is my local machine that I'm sending the ping from. For the sake of time, let's lower the range. We're going to scan from the range 100 to 102 because we know where our device is. As you can see, there was nothing found at 56.100, but there was data found at 56.101. So now we're scanning from our shortened range of 100 to 102. And as you can see, there was nothing found at 100, 101, but there was something found at 102, and this is our device. As you can see, the IP address has changed to 56.102. Now I challenge you to take these output values and determine if the output from ping is a destination host unreachable. This will allow you to determine only what hosts are alive. So in review, we learned that the metasplitable VM is an intentionally vulnerable VM, and we can set it up using a host-only adapter in VirtualBox. We learned how to use subprocess to make system calls and how to pipe those outputs into standard error or standard out, and we developed our own ping sweeper for enumeration purposes.